Okay, welcome back again. So just to continue with the next part of 2018 higher level question C3. This is part C. So it says the terrarium on the right is a cube which is tilted and shaped as shown. The outline plan is a regular hexagon of 150 millimeters sides. Draw the given plan of the terrarium and project the elevation. So this object over here, okay, just a couple little things. On the question, I can see that they've lightly drawn in a circle just to give you a little hint as to the way you can draw this. It's a regular hexagon of sides 150, scale of 1 to 3, so the sides are 50 millimeters. Okay, so you could just draw this by realizing, and again, they have told you just to help you out a little bit here, 60 degrees, but just remember the rule. Anytime you have a polygon, a regular polygon, the external angle is always going to be 360 divided by the number of sides. Okay, so in this case, 360 divided by 6 being 60 degrees. So that angle here is 60 degrees, that angle is 60 degrees. I could just go 60 degrees, measure out 50, go horizontal, measure 50, 60 degrees. I could do it that way. I've chosen to do the same as I've done with the question itself. So basically, from this point, I've drawn a horizontal line. For a regular hexagon fitting or inscribed inside in a circle, and this is only true for a regular hexagon, if the length of side is 50 millimeters, well then the radius of the circle into which that hexagon, regular hexagon, will fit will also be a radius of 50. Okay, so the distance from here as far as here is 50. I've drawn my circle, and then I've set up, through the center point, I've set up 60 degree angles. Because again, if you remember, the number of degrees in a full circle starting here, working around back as far as here is 360. The number of sides on the hexagon is 6. 6 into 360 goes 60 times. So if I set up a 60 degree angle here, and here, and here, and here, and here, and here, I've got 6 60 degree angles making up my 360. Because this here is 60 degrees, this here is also 60 degrees, and this here is also 60 degrees. So we're setting up equilateral triangles. So you have 1, 2, 3, 4, 5, 6 equilateral triangles. And again, this is going back to junior cert drawing, which means that the length of side there, which was 50, has to be the length of that side or radius there, which is also 50. So I've lightly drawn my radius 50 circle through the center, 60 degrees, 60 degrees. I already had my horizontal, and then I just basically had 60 degrees, horizontal, 60 degrees, 60 degrees, horizontal, and 60 degrees, drawing the hexagon. Okay. For the triangular piece that is cut off the base of this object, I can see from the question that it tells that this line here goes at 30 degrees. And if you look at the question, you can see that this corner here meets this line that lines up with those two corners. So the line I've put in pink, from that point, I've used my 30 degree angle, 30 degree set square, to set up that line going down that direction. That gave me that corner. And then went vertical, and on the other side, 30 degrees going that direction. So that gives me those 3 points. Okay. Now, the next bit of this, I've taken the edge of this up here, which gives me that point, and I've taken that corner here as far as here, which gives me that point. Okay. So let's say that happens to be A, B, and C. Okay, A and C are located there. B is located there. Okay, that is the base of the front elevation. Okay, where you can see from the question that this is obviously going to sit at a 90 degree angle. Okay, and to create that 90 degree angle, and they have pretty much told you in the actual question itself, we're going to use the rule of a triangle sitting inside in a semicircle, form a 90 degree angle. So just before I look at that, go over to this sheet here a second. So I've just redrawn this. Just remember this rule. You've probably done it in maths, we'd have done it in junior cert drawing as well. If you have any semicircle, and in that semicircle you draw a triangle whose base sits on the diameter, wherever you put the other vertex of the triangle will form a 90-degree angle as long as that vertex is on the circumference or on the circle. So that's a 90-degree angle. I've just picked random points out as far as there. Draw that, back again. Note for each one of them, the base of that triangle is sitting on the diameter of the circle. That would form a 90-degree angle. Same with this one. Pick a point, 90-degree angle. Okay. While I'm actually on this sheet, just to mention, going back to the polygon in a circle, here's a circle I've just drawn randomly. The rule is always 360 divided by the number of sides, so I took pentagon in this case. Angle of 72 degrees, because 360 divided by 5 is 72. Set up 72, set up the angle that way, and after that I've set my compass to that, and I've just stepped it off around the circle, letting me draw the pentagon. Okay, so it's a junior cert drawing, but something that can be useful as well, depending on what way the question actually comes up. All right, so 2 little points there. So if I go back to this, I'm going to use the triangle in a semicircle to set up a 90-degree angle. Okay, so what I've done is that line from there, as far as there, I bisected it to find the center point. From that center point, I drew a light semicircle. And then the point I want to set up my triangle, my 90-degree triangle, is where the bottom corner of this object would have been if it basically stuck down into the ground. So if it wasn't cut off and the bottom corner of the object stuck into the ground, that would be the bottom corner right there. I've brought that up as far as that point and then joined it back to each end of the diameter of this circle. Okay, extend it on, extend it on. That will give me a 90-degree angle. Okay, how do you know to use that? Very simple, to show you on the question. Okay, if it wasn't shown in the question and they're telling you this is a 90-degree angle, this is one of these things where you just have to associate 90-degree angle. You have this distance. What can you do? You know that this point is going to be along this line. Semicircle, set up a triangle, creating a 90-degree angle. Okay, that extends out. The rest of it is just normal orthographic drawing. The points are brought up. The points are brought up. All these are parallel. That's parallel. That's parallel. Okay, and that gives you the part C of the question sorted. Okay. Last part of this question says, determine the true inclination of the surface D to the horizontal plane, and hence or otherwise determine the true shape of surface D. So this is surface D, which is leaning out at an angle. So in the plan, it's sitting out this way like this. Okay. I can see here, and again, I've just shaded this in, you might be able to read from this here. This section is open. So on my surface D, this is all surface D, this pentagonal shape here. Okay, so that 5-sided shape is surface D. I've just shaded the blue in a little bit darker here because you can see into the object. Whereas this one, you can still see B, but it's been obscured a certain amount by the glass that is sitting on that surface running down along here. Okay, but it's still on the one surface. So the true inclination of the surface D to the horizontal plane. Okay, basically if we go back over to this part of the question, there's surface C. Okay, here's an edge view of the horizontal plane. There's an edge view of surface C. The true inclination or the true angle that surface C is sitting at or inclined at or leaning at, whatever way you want to look at it, to that surface is contained here. So if we were asked for the true inclination of surface C to the horizontal plane, it is contained in that view there. That would be the true angle of inclination because that's an edge view of the horizontal plane. Okay, let's go back over here with this. So we're going to do basically the exact same thing with this as we did with this one. Okay, so the rule is always going to be the same. If you didn't have a horizontal line on the surface, draw a horizontal line on the surface in front elevation. Bring that down, draw it as plan. Okay, that will be a true length in plan. Look along the true length in plan will give you an edge view of the surface, will also give you an edge view of the horizontal plane and hence the true angle of inclination. So on this surface D, I look first of all before I do anything else to see have I a horizontal line? I do. This line here as far as here. Okay, so A as far as B. Horizontal line, bring it down. There's my horizontal line in plan, A as far as B. That line is a true length line on the surface D. Okay, so if I look along that true length line on surface D is going to appear as an edge U. Okay, but because that line is also parallel to the horizontal plane, remember this is an edge view of the horizontal plane. The XY is an edge view of the horizontal plane. Because this line here is also parallel to the horizontal plane, well, it's actually on the horizontal plane. When I look along a true length line that's parallel to a plane, I also see the plane as an edge view. Okay, so I will see surface D as an edge view, and I will see the XY line as an edge view. Sorry, I'll see the horizontal plane as an edge view, which is the same thing that happened over here. Okay, so I am going to look along, take this way. I'm going to look along my line AB. Okay, I'm going to set up an XY perpendicular out here. Okay, I am going to bring out my other points that I need there as well. So on the object, I'm going to bring that out, and I am going to bring that out. Okay, so while I'm at it, so I've had ABC, I'm going to go with D, E, and F. Okay, front elevation. E is sitting there, D is sitting here, and F is there. Okay, so my surface is A, B, D, E, F. Okay, bring my points out here. Current view, last view, second last view. Okay, so the points that are on the ground, point A and B are on the ground. They are going to appear as a point view. A is first, followed by B. So A, B. Okay, sorry, just put in, I'm on X2, Y2, depending on if you've done your dihedral angle, you're on maybe X4, Y4, doesn't make any difference. My auxiliary XY. This is currently an edge view of the horizontal plane. Okay, A and B appear as a point view. F and D are going to be along that line. Okay, I take my height for F and D. So from the XY up as far as point F, I think you'll find is the same for point D. So F and D are along this. Okay, and finally point E is at that height. So I'm doing this quite fast. Point E is there. So that is E. And as I look at this, F is first and D is second. So when I join these together, these should line up. Now this one's off a little bit because I'm kind of running through it fast. If, when you go joining these points, okay, so we're supposed to get an edge view, so all the points should line up. My point F and D is off a small little bit there. Okay, it's not much. It's not enough for me to go back and figure out what exactly is wrong here. There's something off very slightly someplace, which is giving me a slightly different height for one of these. Okay, just line it up as best you can. As long as it's not off by 5 millimeters. Okay, if it's off by a millimeter or two, I would be inclined to say, rather than going back and wasting trying to fix it, get it drawn in. Okay, so that is an edge view of surface D. Because it's an edge view of D, and that's an edge view of the horizontal plane, the true angle of inclination of surface D to the horizontal plane is that angle contained between there and there. Okay. And finally it says, hence or otherwise determine the true shape of surface D. So I would do the exact same with this as we did back over here. Take that surface. This is our true length line. That is going to become our hinge edge. So again, our surface is sitting like that. drop it onto the ground. Over here, that's going to appear as the edge view, rotating about point AB, which is going to be the hinge, onto the ground. Bring point E back here, move perpendicular, bring point F and D onto the ground, bring them back, move perpendicular. You're going to get a larger pentagonal shape, which will be the true shape of surface D. Okay, so hopefully that helps. Again, if there's questions on this, you can ask at the bottom of this video, or you can contact me through Classroom or the email. Okay, so as I said, hopefully this has helped some of you out. Again, if you need clarification, send your questions. Okay, thanks for watching.